Hi everyone, you're welcome once again to our channel. We will be looking at the beginner's guide to SQL. We'll be looking directly at the CRUD operations. So using the CRUD operations. The CRUD operations are CRUD, C for the C, R-U-D, create, read, update. Operations used by an analyst daily for his operations. Now, to get us started, we will have to import. To get us started, we're going to import a database into the system. As an analyst, your work actually starts with analyzing already existing data sets, so you don't literally have to impute them yourself. So we're going to import something and then use. If you check on the description of this video, there is a link to the imported file, which you can download and also use alongside with us. To import the database, you're going to come to SQL, click on Create Database, and then open. Now, once you have that done nicely, you're going to run the file right here. So you can click on this, and that will be perfect. That would run, and you're going to find the files right on the schema. Yeah? So we'll get straight in there, and then we'll begin to work on the file that we have. Now, when you've done that, you're going to have these databases created. You have the HR database, you have the SQL inventory database, you have the SQL invoicing, SQL store. All of these you're going to have created already on your system. Now, for today, we're going to start out with using the SQL store, exploring the SQL store. Now, of the CRUD operations, so I'm going to write it as CRUD operations, which invariably means create, read, update, and delete. Of the CRUD operations, we're going to be focusing largely on the read operations for today. On this video, we're going to be focusing largely on the read operations. Now, let's get started. First and foremost, because I don't intend to use this file, it's a comment. So I'm going to use the to, and that turns that into a comment. Yeah, it cannot be executed. It's a comment. So when you use 2 dashes and a space, that becomes a comment. Now, having said that, let's get into the very first read operation for today. Now, for the first thing you would want to do is you've got a couple of databases on the schema side of things. And once you've got a couple of databases on the schema side of things, you want to be able to identify which of the databases do you want to use, do you want to read from. Now, the very easy way to identify which database you want to read from is to come here and just double click on it, and that activates it. Yeah. Now, SQL HR is activated. If you click on SQL invoicing, that becomes active. And if you click on SQL store, that becomes active. Now, but if you don't want to go ahead and use your mouse at all, you want to stay with the keyboard, you just type use SQL _ store. Yeah. Now, this is absolutely correct. And then you run it. Now, when you run it, did you notice something? It activates the SQL store. Now, watch the bar on the side, meaning SQL store is activated. Now, having done that, we could try another one. And then you're going to run it, and you watch it activates the SQL HR. Now, if you don't have, for today, we're going to be running first. Initially, we're going to start with SQL store. So I'm going to run this, and that activates it for me. Now, if you don't have any other statement on this sheet, then you don't need to put the semicolon. But should you ever have another statement on this sheet, then you have to come up with the semicolon. All right. Now, having said that, because we have another statement coming on board, we brought in the semicolon. Having done that, let's go for the next step. The very first step could be the fact that you want to select, you want to learn you want to read from the database. Now, if you come to the database that we'll be using, SQL store, so you could come in here and just click on what information. Yeah, check the tables. Look at this. It's got a customer table, an order item table, orders, shipping. These are the tables that are contained in the database. Again, you could stretch it a bit further and you could see that there are columns that are contained in each table. So for the table customers, there are a couple of columns that are connected to it. I hope you can see that, my friends. And then the type of the columns, yeah, and perhaps other informations and privileges you may need to know about them. Now, having seen that, I will start my journey looking at the customer table. So I want to get into the customer table. Let's see what happens there. Now, select. All right. So you use the asterisk and then from SQL store. Now, I'm just going to say customers. Yep. Again, if you don't have any other statement coming up, this is very okay. Now, this is a good way to write. As well, you could write it this way and you would still be correct. Now, what do? You could run this and then that's it for you. It creates exactly, it pulls out the data set in that column for you. Let's see. So we have 10 customers, as you can see, 10 customers. Whether we do these or we do this, you would still be correct. Now, what does the asterisk here mean? The asterisk here means every field. You see, this is a field, another field, another field, another field, another field. So another field, another. Every field in on the table, pull them. Yeah. So it pulls every field. Let's begin to narrow these a bit down. Now, we could say, instead of asking it to pull every field, we could actually go ask it to do customer ID. Yeah, we could ask it for first name. And we could ask it for what? Last name. Now, when do you have to do this? Particularly when you have to narrow your search, is when you don't want to pull everything, because as the more things you pull, the more memory that is affected, the system capacity, the processing power is being dragged down. So you don't want to be pulling everything, rather narrowing to the exact things you need. All right. So you have these, select these, run it. Okay, now that's narrow. Customer ID, first name, last name. So when you need to see some particular informations, you narrow your search just the way we did. Yeah. Now, having said that, I'm going to take this up again and I'm going to go right back to where we began. Again, whenever you want to, like I have a couple of commands here, a couple of instructions here. For me to target a particular instruction, I have to select it and then run it. Okay. Yeah, I could go ahead and add phone number to this and then select these and run it. Now, there are things we call a good naming nomenclature. And then if you stay with me, I'm going to walk you through it. The very first one is the fact that, have you noticed that every SQL function like select, like from, is capitalized? Yeah, those are good naming nomenclatures. However, it is essential that you note that SQL it's not case sensitive. SQL is not case sensitive. So if you did something like this, like select with a small letter, and you did this small letter, and then you run this same code, you would still be fine. All right, good job. Now, but however, your spellings need to be very accurate. So if I miss an S like this, so instead of customers, I have customer, and I select this code and I run it, I'm going to have an error. Okay, awesome. All right, awesome. Now, we'll take this a step further, and then we're going to introduce the where function. So before we introduce the where function, let's run this one more time and see what it looks like. Let's say we wanted to be able to identify not only all the entries in the customer table, but we want to use where customer ID is greater than 4. Does that make sense? So you want to look at all the entries where the customer IDs are greater than 4. You see, the where is a filter function, and then you run this. Okay, have you noticed that everything it filtered was actually things that were greater than 4? So it creates only the view with all customer IDs greater than 4. Now, one of the things I want you to observe is the fact that when we did this, it just says 4. But let's flip this a little bit. We're going to use, instead of using the customer ID, we're going to turn this around and we're going to say first name. Now, when we use first name, we're going to go for equals to sign. Now, but when it comes to a string, because first name is a string, when it comes to a string, you have to use the apostrophes, the braces. You have to put them between apostrophes, exactly this way. So I'm going to put Elka. When it was a number, we did not have to use the apostrophes. But once it's a string, we have to use an apostrophe. Yeah, you would find that very common across many other data applications. So let's see how this works. Awesome. It did just perfect. All right, lovely. Okay. Now, another place where you would have to use apostrophes when you are writing the outcome is when you are using dates. So if we put the birth date, and then we say 1992, 01. Now, because it's date, we also have to use the apostrophes, else the system will throw it up as an error. Oh, we don't have anyone around that date. So we're going to say, let's use the greater than sign. So you have birthday is greater than this. So let's try that again. Oh, can you see this? So these are the ones that have their birthdays greater than, 10 of them have their birthdays greater than 1992. But it would be good to see if we made any mistake. So we're going to check this one more time. Let's check this one more time. I'm going to take this off. We'll select these, run it. Yeah. Birthdays are all okay. So we've got only one person or two that should be able to now birthday. Now let's see what we did there. Oh, there is no word like birthday. It has an underscore. So little things like this could actually become a downside for you. So, all right, let's go run this. Amazing. So this and this Thatcher and Romola are the only two individual customers who have their birthdays greater than 1992, 1st of January. Now, for now, I'm going to remove these regions so I can have my view better. I'm going to take this off by clicking on this. I have a better view. All right. What other thing can we do? So let's make this a bit lower. Let's go as far as 1987. Yeah. And see how many we've got when we do that. Oh, we've got 3 individuals who have their birthdays above 1987. Let's introduce another interesting function called the order by function. Order by. So we're going to say order by first name. Yes, now watch what the outcome looks like. The first one that threw up itself here, in this regard, the system ordered it by the customer ID, so 689. Yeah, but when we ask you to order by first name, it will sort. It's a sorting technique. So watch this. You notice, instead of Thatcher coming up next, Romola became second. So the order by is actually a sorting technique. All right? Now, speaking about order by, we mentioned that order by is actually a sorting technique. And as you can clearly see, it sorts this thing in an ascending manner with E coming first, R coming second, and Thatcher coming third. Now, should it be that you want to create this or sort these in a descending manner, what do? At the end of first name, you come right there, put the DESC. So that means descending. Yeah, that means descending. Now, if you select that and run the file, you would have Thatcher coming up right first, Romola second, and you're going to have Elka coming right at the third. Okay. Now, we've looked at the select function, we've looked at the from function, we've seen how the where function was, order by, and we've looked at how to order by either ascending and how to order by descending. Now, it's important to note that they are what you call calculated fields. Yeah. So, take for instance, we want to calculate points. You see points? So the point, every student had, or every customer has been awarded 100 points. At the turn of every year, every customer gets awarded 100 new points. Now, for this scenario, what can we do to make this look really solid? So we can come to phone, comma, we could say points. Love that, points. And we can say comma, we could say points, plus 100. Now, if we run this code, my friends, watch this. What have you seen? The customer ID, the first name, just like we asked for, the phone number, the phone number, what else do we have there? The points, and we have point plus 100. Point plus 100. Now, wouldn't be very, and if you look at the calculations, you can see 100 is added to this to arrive at this, 100 to this to arrive at that. Every one of them has 100 points added to them. Now, you see, this is point, and it wouldn't be a very good way to call a field like this just point plus 100. So we're going to introduce a new function called the as function, And in this as function, we're going to call it new underscore point. Okay. Now, one is asking, what if we use new? So we're going to try this first. Watch this, run it. Do you notice the name is a name change? So the as function is used whenever you're going to implement a name change. The as function is used when you're going to implement a name change. I hope you got that. Amazing. Okay. Now, next. The next thing is you're going to be wondering, how come we don't keep spaces? So let's try keeping a space. So new point just the way it is. And then we're going to try running this code. The system does not appreciate this spacing. If you want to name this without a space, you're going to have to use is it parentheses again? What do you call this? Or apostrophes or parentheses. You're going to have to use it this way. Now, let's say you named it, let's call it new. I'm going to make it distinct, so I'm going to put a D there, just so that you see it's coming different. Run that. So you see, it's either you do it, you use no spaced character, no space character, or no space word, or you use parentheses to hold a spaced word together to arrive at what you are trying to arrive at. So well done, as you also get to embrace the as function. Before we go ahead to discuss anything further, it would be good for us to look at what we call operators, comparison operators. I'm going to show you a couple of comparison operators. Now, the very first of them, which you have seen us use with birthday, it's the greater than sign. All right, the greater than sign. So this is for what? Greater than. And likewise, you've got the less than sign, the less than comparison operator. What else do you have there? You have the greater than or equals to. Greater than or equals to. Yeah, equals to. Yeah, got that? You also have the less than or equals to. You have the not equals to. So take this off. So this means greater than or equal to. And this means less than or equal to. All right, good. Now there is one more or two more we need to know. When you have the greater than sign together with the less than sign, what you mean is not equal to. And when you have the exclamation sign together with the equals to sign, you also mean not equal to. So a negation. These, my friends, are what you call the comparison operators. Please take note of each and every one of them. Okay, having said that, I'm going to take this off. Make sure you keep an eye on them and you have them saved somewhere so you can remember them. All right, good. Okay. We're going to introduce another operator, and this time around, it's going to be called the AND operator. AND, or, and, slash so the and slash or operator. Yeah. Now I said to you earlier that when you want to put a statement in a when you want to put a statement as a comment, you put 2 hyphens. So make that a comment. All right. Now let's start by looking at, again, we're going to be using the customer. So I'm going to copy this. Let's reuse it. I'll take this here. So customer, and then we're going to say where. Now we're giving it a condition. You know, the where statement is a filtering statement. So in this case, I'm going to use the birthday. So perhaps we should just, let's extend this one. So I'm going to extend this one. So where birthday is greater than this, I'm just going to say where birthday is greater than 1985. Yeah. And what else should we use? So let's use where birthday is greater than 1985. And also let's go with when birthday is less than. So birthday is less than 1999. Does that make sense? Okay, I think it does. I'll take this off for now. Take the other for now. Okay, now let's run this to see. Now, what did you notice? We said where birthday is between is this greater than this and less than this. Now let's see where the birthdays are. Now look at the birthdays. We have 1986, we have 1986, we have sometime in 1985, we have 1991, which is all right, 92, 93, but we can't have anything 1999 or 2000s. Can we reduce this to 93 and see how this sieves this fall off? All right, cool. Now that takes out, yeah, some of them. Now this is a very beautiful condition called the where function because you could narrow in. It helps you filter all the more within limits. Yeah. Now, alternatively, how about if we try something like with the or? Now, it means that when you use the where, the and statement, it means that this must be true, the first expression must be true, and the second expression must be true. Does that make sense? Both expressions must be true. All right. Now we're going to change this to 1989, greater than this. And we're going to turn the and statement from an and to an or. And we're going to say or, and we're going to use points instead, just, yeah. When we use points, what are we going to have here? We're going to come here and we're going to say points, and we're going to say points should be greater than 1,500. Because it's a number, we don't need the quotation, so we take it off. It's a number. Now look at this. Now, whenever you use the or function, you mean that at least one of the expressions is true, at least one. Now, let's see how this pans out for us. Let's run this and see where it takes us. Now, look at number 1. Is the birthday greater than 1,000? Is the birthday above 89? No, it's not. It's less than 1989. However, the points are above 1,500. So this can fly. You see, at least one of the expressions is true. Look at number 3. It says 1985, which is less than this period. However, the points are higher up. Yeah. Now, you have this interesting one. Come to number 8, customer ID 8. it is absolutely, this agrees, so this is good. 1993 is very good because it's above this, but the points are less than 1,500. But because one of the expressions is true, the or will pass. It is expedient that we remind you that if you go down to the description of this video, there are exercises that you can use to practice and get your hands dirty with your SQL knowledge. So please download the exercises and make sure you treat every one of them. Yeah, let us know your feedback on the comment and where you would like us to add some more videos and value. Let's have a new conversation around the not function. Not function. So I'm going to the not operator. Speaking about the not operator, this is like a negating operator. Now, be careful how you use the not operator because it can completely alter what you mean. So take, for instance, if I pull in the not operator here, what do I know? Now, if I run this code, you're going to have an interesting experience. Watch it. Now, you see when you said birthday must be greater than this. Because of the not operator, the real outcome of these means, because of the not operator, you're going to have, what that means really is this, that birthday must be less than or equal to this. So the not operator negates what you said here. So you would notice that the birthdays here are going to first and foremost be less than or equals to this. So let's see, look at them. You see, this is less than, this is less than, this is less than, this is less than, this is less than. These ones are more than, 1991 is more than, so mark that. This is less than, this is less than. The only reason why 1991 makes it on this list is because the point, it's more than 1,500. And that's why that makes a way there. Now, if you flip this the other way around and you say, and, yeah, and you go, poof, let's see how that works. Now, look, don't forget, because of the not being here, this is what it really means in essence. You will notice that everything here will be less than or equals to 1989. Look at it. All of them are less than 1989. And all of them are more than 1,500 in terms of points. So the not operator, it's a really strong function. However, it depends on how you use it. You see, when we place the not function here, it only undermined the outcome of this expression. Should we want to make the not expression to actually come attack the whole expression, we could open a brace here, open another brace here, close the brace. Now, before we do this, it will be good for me to first, let's do this. Let's take this off. I'll take the not out. So, and I'll take the not out. Yeah, watch this. So let's try this out first. Run this. How many do you have? You have only one outcome. Only one customer has their birthday above 1989 and with a point value of greater than this. Now, when you put the not function here, what this will do will be, it will negate this. So every other entry that did not satisfy this outcome You see number 6, customer ID 6. Let's run it. Now you notice every other entry pops up except number 6. Every other entry pops up except number 6. The reason being that it negates everything you had here. So the not function with the brace around it negates everything in the brace. Awesome. So once again, let's imagine that we want to select particular customers who are from particular states. So first and foremost, select from customers. We run this. Now this gives us a list of all the customers we have in literally every state. Yeah, we're going to take off the comment from this and take it right up there. Now, if we want to figure out customers who are from particular states, in this case, VA, GA, Florida, yeah, Georgia, and all of that, Virginia, Georgia, and Florida, then we have to take it this way. So state where state is equals to this, or state is this, or state is from that. Now, based on the AND or operator, which we had previously looked at, then that's the way to go. Yeah. Now, but if on the flip side, if we run this now, so we select this and we run it. Now, it narrows the search and only provides us with it only provides us with customers who are from the 3 states, Virginia, Georgia, and Florida, as you can see. Now, but imagine how many ORs you would need to use if you had to do like 3 or 10, 15 states. Now, there is a way we can get away from using the ORs by simply using the in statement. So I'll take off the where statement here, and then we'll bring on the where statement here. Now, by doing this, you see, we're going to achieve about the same thing. So the in operator allows you to, it searches the braces to see what is in the braces, Virginia, Georgia, Florida, such that when you run this statement, you're going to get exactly the same result as you got if you use the OR operator. So the in operator, it's a very good replacement for the AND or OR operator, particularly when you are looking at multiple comparisons. Yeah, so there you go. Now, having said that, another good operator we're going to be looking at, it's the between operator. Now, this is where you would love to see the between operator doing its magic. Now, when you have a statement like this, select customer, select everything from customer, where point is greater than this and point is less than, let's go to 3,000, yeah? So you mean between a range, yeah. If you run this, you're going to have an outcome like this. Everything here is within 3,000, as you can see, within 1,000 and 3,000. Nothing is more than one, less than 1,000 or more than 3,000. Now, these statements could be written a lot simpler. And how will we do that? We're going to take off the comparison operator and then bring in the between operator. So we're going to have between 1,000 and 3,000. Does that make sense? So between these range, and then we run it. And you're going to get exactly the same result. So the between operator is a good replacement for the AND operator. Yeah, okay. Now, it is Now, it would be good for us to also look at the like operator. Yeah. The like operator uses a few sets of characters for its operations. Now, let's look at the characters that it uses. But before we go in to speak about that, look at these. When you use the forward slash, look at the forward slash and an asterisk, and then you use the asterisk at the end of a block of sentence. So this is a block of sentence. You have a forward slash, you have asterisk, you have asterisk, you have forward slash again to close it. When you do this kind of thing, that's a comment. You've made this a comment, and this cannot run. Yeah, it's a comment, so it can't run. So I've shown you two ways to write comments. One of the ways is using a double hyphen, yeah, and another way is to put them as a block of comment. Now, having said that, let's look at each and every character that the like operator uses for its functionality. Now, the first one is the percentage sign. And the percentage sign means any number of character. Now, let's start by running this code, the select customer statement. Run this. Now, I hope you understand, again, just to remind you, that the reason why we're using select cost from customer is because the database that we have active is the SQL store database. Now, if you weren't exactly sure, just so that you don't make mistakes, a very good rule of thumb is to write your SQL underscore store. So it calls the database, then calls the table. So if you do this, select this, run it, you would still get exactly the same result. So it drills into the particular database. Now, having said that, let's use the where clause. So we're going to say where last name. So let's look at the last name is, what should we use there? Let's go with the, yeah, bring it in. Now, we're going to use the percentage sign. So we're going to say, we go with a B, an A, an N, or a T. What do we have much of? An M. So we go with M, and then we use the percentage sign. All right? Okay. Now we're saying select from everything from SQL store, where last name, the last name there has to come with, yeah, spell it properly, and then M, and then the percentage sign. So we select this and we run it. Now, look at this. Look at this. It says any number of characters. So you see, when we use the percentage, M percentage, it filtered everything. So last name had to start with an M and then any number of characters. Can you see that? Any number of characters. Okay. Now, let's try B. B. All right. Let's select that. You see, it had to start with B and then any number of characters. Amazing. Now, the simple underscore. Now, how does that work? Now, how does this work? The simple underscore. So I'm going to go with I underscore ES. And this time around, I'm going to be going for first name. Yeah. So what does this mean? It means a single character. So the underscore consists or stands in for a single character. Now, should we run this code? You see, there's a single character missing. That's why you use, whenever there is a single character missing, that's when you use the underscore. And you see, the ines has a single N missing, and that's why it captured this. Now, if you used I with the underscore, and then you went with selected this and ran this, it will give you a null because there is no first name that is just an I with a single character. Yeah. So, however, if you use the I with the percentage sign, these will give you every first name that starts with an I. Amazing. I hope you can appreciate how this works. Now, I'm glad you can see how the percentage and the underscore character works with the like operator. You can actually do a lot more with this. So you can have something like, which means a number of characters exist before the I and a number of characters exist after the I. Now, we could check this out too and see if there is anyone. And you can see from first name, if we look at the first name, we've got Ines, we've got Eddie's, Clemmy, a number of characters before I and a number of characters after I. Now, it could be a number of characters. It could even be no character. Yeah. Okay. So that works pretty well. Now, having been able to look at the like operator, let's look for a more powerful operator that can help us do a lot more than what the like can do. Now, the operator we're going to introduce is called the regex operator, and it will use all of these characters, not just the first two, but all of it. Now, I'm going to introduce right away the regex operator. All right. Now, the regex operator could be used to check something as small as just field. Yeah, so I think the last name, we use that for last name. Okay. Now, if you see the field, the regex, it checks for every last name that has a field in it. And there is one exactly there, Bushfield. Yeah. Now, as well, you could do something like this. You could put the it means it has. Now, this outcome that you have, if you were to achieve this using the like operator, it would have looked like this. So I'm going to copy this, paste it here, and I'm going to turn this around to a like operator. But for this to have been to work, you have to put the percentage here. That's the only way you would have gotten this to work for the like operator. But with the regex operator, which is more powerful, it can search for every thing without necessarily having the percentage or the underscore in it. Now, another good and powerful thing we can do with the regex operator. So let's use the regex operator a bit more. We can say, let's take this off for now. Okay, we're going to say, based on what we've seen here, we're going to say, let's figure out any last name that starts with, you see, can you see the upper sign, this sign? If you put this here, yeah. So it means it must start with. Now we're going to check for a last name that starts with an R. I think we should look for one that starts with an R. So it must start with an R. If you select that and run that, that will pull everything that starts with an R for you. Now, if you turn this around and say a B, so it means everything that starts with a B, it will pull everything that starts with a B for you. On the flip side, if you put the dollar sign like this. And you run this, V doesn't work. So I'm going to take. So on the flip side, if you put regex dollar and put a Y there, put the dollar behind the Y, and then you run this code, it means every last name that ends with a Y. Every last name that ends with a Y. Yeah, so the regex, you could start with these, everything that ends with a Y. And when if you want to find everything that ends with a Y, you put that at the beginning and put the letter. And if you're looking for everything that starts with a particular thing, you put these in front and then put a letter. So you could put these and then put a B beside it. And then if you're looking for everything that ends with a particular letter, let's say letter, say Y, you put the Y in front and then put the dollar at the end. Amazing. Okay. Now let's look at one other way we can use the regex. We've looked at how to use it with the must start with. We've seen how to use it with must end with. So let's figure out another way we could use the regex formula. Now, we're going to use the or symbol in regex. And in this case, we're going to be looking at last names that have in themselves son, and perhaps have in themselves the word Lee. So if any last name has either of these words, either son or Lee, that's the thing we're trying to figure out. So we're going to select that and run that code. Betchley and Dawson. You see, Betchley and Dawson. Another good use of regex. Let's identify another nice way we could use regex. Take, for instance, you have options like this. So I'm going to take this off first, and then we're going to take some bearing with our code. Yeah, so based on what we have in there, cool. Yeah, we'll take. So we're going to see we're on last name. So I'm going to look for any last name that has any of this. So we've got SE, so I'm going to have S, E, we're going to have B, and I'm going to have R. So if it has any of the sets of words, SBR before an E. Now let's see how this works. Run this code. Now watch on the last name. You have a name that has, the first name has an R before an E. See, an R before an E. Likewise, the second name has an S before an E. Can you see that in the Rose Bowl? The third one has a word, and there's an E. There's a B before an E on Betchley. So you see the B before an E, Betchley. And then there is also an E, an S before an E in Nasby. That's the one. So it selects these based on these statements. These are really good uses of a regular expression. Please remember to check the exercise we have on the description to do some practice work based on these understandings. Just like you had a combination like this, you can as well have a combination like this. The E coming on its own, and then you have these entry. Now let's see if we have anything that works like that. Oh, we have an E before a B, so there is an EB. We can see that in Roseburg again, and there's an EB here, and that works perfectly. Yeah. Now, another way we can have these is we can have it like an A to D. A to D, meaning any alphabet between A and D. Yeah? So if we run this code, again, we have EB, EB. Yeah? But if we extend this to A to S, we will have a lot more because we have EB, we have EL, we have EB, and we have EL. So we have a whole lot more. So the combinations could be different, but you can see different ways you can use the combination for a regex formula. All right. Allow us to introduce to you what we call the null operator. Null operator. Now, take for instance that we want to look at this same data set. We're going to take it off from here, take this off from here for now, from customer, where phone numbers, we're trying to see how many of the data sets that we have phone numbers that are less, how many people did not give us their phone numbers, more or less. So where phone, we have phone here, is null. So is null is written separately like this. Now, if we select this and we run it, you can see this person, Clemmy Betchley, did not submit a phone number. Now, you know, we can as well negate this to say not null. So allow me to introduce to you the limit function. Now, if we run this query, it's going to drop off all the data set. And sometimes because of memory usage, computation power, you want to limit the entries that are coming out. You don't particularly need everything. So let's say you could say order by points. So you want to see the points, the ones with the highest points, and this time around in descending order. Yeah? So you run this code. All right, that's so good. So it orders this by points and puts it in descending order. Now, what you particularly wanted to see was like the first 5 people that had the highest points. So what you could do is just click the limit function and put 5. You know, this allows you to limit all that will come to the first 5 with the highest points. So like saying top 5. And there you go. Your top 5 is here. Just in case you want to go for a step further and just limit it to the top 3, you could change this to what? 3. And there you are. Now, another thing you can go ahead to do would be the fact that sometimes you want to go and look at perhaps the last 3, yeah? Already because you already know you have 10 rows, you want to say skip the last 7 and then take me to the last 3. So it's going to skip the last 7 and take you to the last 3. So let's see how this pans out. We'll select these and then we run this code. Now it's going to filter you to the last 3. It has skipped the first 7 and it generates the last 3 for you. So the limit function is a really good function to use to do things like the top 10 or the bottom 10, top 5, bottom 5 kind of thing. Yeah? All right. Now, we're going to get right into another very interesting part of learning SQL. And this is when you use what we call the joins. Up until this time, we've been working on just one table. And the table we've been working on throughout today has been the customer table. But now you're going to see how to connect more than one table and be able to extract data from more than one table. So let's get started talking about joins. Our very first join lessons will be joining within the same database. Now, let's look at the database that we have been working with, SQL Store. If you click on the information box like this, it'll take you here, then move to columns. You can see, if you look at the table, you have the customers table inside that database. You have the order table inside that same database. Now, the easiest way for us to write a join statement, it's pretty much this simple. Select asterisk, which means every field in there, from orders, then, or let's say from customer. So let's means we take customer first, but let's take orders first. Orders, and then join it to what? Customers. Now, these will implicitly join the two tables. If you select these and you run the code, it will implicitly join these two tables. However, when we mean an implicit joining is the system just finds a way to join it. Yeah. However, it doesn't mean that it has joined it correctly. Now, for us to get these to be joined appropriately, we must define a basis for joining these two tables. So let's go with trying to find a basis. So you use the on operator when you want to create a basis. So you say orders. So you're joining orders. You're looking at the customer ID. Yeah. That's a field in orders called customer ID, as you can see it here. Yeah. And then you are also saying when this is equals to another field in customers called the what? Customer ID. Did you see how nicely we use it? You call the first, you call the what? The table, and then the field, and then you call the other table, then the field as the basis of the join. If you select this, you're going to have a better join. Now you see, instead of, if you look at what we had earlier, now if you look, there are, look, 1, 2 to 10 orders. Can you see? 10 orders. And then it maps them really nicely. Now, if we take these off, 10 orders really nicely, if we take off these last statements, and then we run this same code, you can see 10 to 1, then 10 to 1, then 10 to 1. There is no real clear basis about the join. So by putting this in there, we give a clear basis around the join. Now, what you can do is we can actually come in here and decide on the things we want to see. So first, customer ID. We would like to see the order ID. We would like to see things like the order dates. Yeah. We would want to see the status of the order. The status of the order. Yeah. What else would we like to see? So 1, 2, that's a 3 here. The status of the order. What else are we going to like to see? Shipper's ID, customer ID. So the customer who made the order itself. So we're going to be looking at the first name. Should we do? Let's see the customer ID. Now you're going to also want to see the first name of this customer. First name of the customer. Yeah, okay, we can stop right there. All right, cool. This code will likely not run, and I'll tell you why. But for now, let's go see how it works. Now, this code is likely going to have a problem because of this customer ID. And the reason why it will have a problem is because both tables, orders table and customer table already has, each of them has a customer ID field. So we have to decide which of the tables it should draw it from. So in this case, I'm going to just use, and you can use, the truth is you can use any of the tables in that regard. Yeah. So for now, I'm just going to go with these right here. Then we run this code one more time, and you're going to have order one, the order date, the status of the order, and then you're going to have the customer ID, who the first name of that customer really is. You see. So take note about this. You need to define the table from which you take this name from. All right, having said that, one of the things that we need you to understand also is that implicitly, as in by default, every join statement is an inner join. So I'm just going to write it here, inner join. So even if you wrote join or you wrote here, inner join, you would still get the same result. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so if you do the same thing, you will get exactly the same result. All right. Now, but on the flip side, if you turn this around, because there are two kinds of joins. If you said it was an outer join, yeah, if you use an outer join here, then you would have a completely different result. But for now, we'll stay with the inner join, and then we'll talk about the outer join much later. Now, this beautiful work that we have done, we can as well write it out in a completely different way. So I'm going to copy this, replicate it. But this time around, what I'm going to do is, watch me, I'm going to give orders using alias. So the orders will have an alias of O, and then the customer will have an alias of what? C. Now, because orders have an alias of O, I have no reason writing an orders here again, because if I do that and I select these and run it, that will throw an error. Because we've given orders an alias and given customers an alias, we have to change this to an O, and then we have to change this to a C. Likewise, we have to come in right here and turn this into what? A C, because there is an alias in the picture right now. Got that? All right, I'm going to select this, run this code, and then you're going to have your beautiful output right there. Okay, amazing. Okay, we're going to go a step further to look at how to join data across more than one databases. So we have looked at joining data across two tables in one database. We're going to go forward to look at how to join data across more than one database. Now, before we go ahead to learn how to join data across different databases, let's look at how to join more than two tables within the same database. Now, if you look at what the outcome of our result is, we've seen order one, and then the status is displaying as what? 1, 2, 3, 4. We don't have an idea what the meaning of this status is. For us to be able to know the meaning of this status, we need to go get from another table. Now, just like you understand this perfectly, I'm going to add a new join statement right below that. So I'm going to say join Where am I taking this from? We could take an inference. I'm going to take from order status here, which is a table that manages the status of every order. Yeah, so I'm going to come right back in there. I'm going to say order status. So order status. So you're going to take, yeah, pick that up. Give it a name. Let's call it OS. Yeah, OS, order status. Again, once you've called the join, the next thing you have to call is the what? The on. So I'm going to call the on. So on status, which is the O status, because it takes bearing from the order table, the status in the order table, and we're saying try to connect that with the OS order status ID. So we're connecting these to the order status ID because we want to be able to call. We want to see what is there. First and foremost, I'm going to take this out. I'm going to take this out. And maybe I'll just bring in the asterisk so that I see all that there is in there. So select these and nail that. You see, it's looking really long, but let's see what we can get from here. Name processed. So this is what we're looking for, name. So I'm going to come back here, replace these, put a comma in here, put a name, which is the status from, this is from name. Yeah. Put the name there. All right. Select these now. Now, if we put this name here, you wouldn't know what the name means. So I'm going to put the alias S as status. Make that make sense? So I'll take these off. The first status, because I don't really need the number. What I really need is the correct status. So I'm going to select this and run it. Run this. Amazing. Order name, order date, customer ID, the first name of the customer. The status is that it's being processed at the moment. Amazing. So this is how you connect more than one table. You pull things from different tables and then push them all at once into a view. Okay, good. Now, we have seen how to do basic joins between tables in a database. We're taking it a step further into looking at tables from different databases. Now, we're going to be looking at the database which we've been working on from the beginning of today, which is the SQL store. You see, it's a database of its own. And we're also going to be looking at another database called the SQL inventory. Now, you can come with me while we explore both databases. So look at the SQL store. Yeah, you have the customer, the products, the orders, the order status. So you have products in here. And then you have another in the SQL inventory. The only table you have there is the product table. Now we're going to try to connect these, to join this and see where it takes us. So first and foremost, the first thing you could do is you should specify the database you are calling from. So this is how I will do this so that I never get to forget. So I'm going to be going in to draw the table, order items, and I'll call it OI. Yeah. Now, I'm going to join it, but this time around, I'm joining it to a new table because it's the SQL underscore inventory. You see, it's nothing different from what we did the last time, just that now you are specifying the database from which you are calling this from, dot product. Yeah, and here I'll call it a P. Yeah. Now, here I'm going to call this OI because that becomes the basis, the alias from which I'm pulling this up. And then I'm pulling the product ID as against P, where I want to also connect it using its product ID. Now, the good thing is, in this example, it's this easy and straightforward, but it's appropriate that you figure out what is the right fields of connection. They may not exactly have the same names. So it's in your place to find out what the appropriate name use is so that you don't make mistakes. Okay, so I'm going to select this and I'm going to run. Okay, that didn't work. So let's run this. That didn't work. There's obviously a problem on this code, and it would be good for you to look very closely at the names we use. So SQL store order items. Let's check that out. Oh, we see it's order items with an S. So let's see order. There is no S here. There is an S here. Okay, let's try that again. Select that and run it. And there you go, order item 2. This order item 2, the person bought product ID 1, quantity, unit price, product ID. So the person who bought it, the name of the person was foam dinner plates, quantity 70, unit price was this, and all of that, my friends. So you've been able to map these together. You can as well go in here and filter for the specific fields and columns that you are more interested in. Okay, so that is it, how to connect databases, tables within two databases together. Now, should you want to extend these also, you could as well add another join statement and then call in another table from another different database as the case may be. Now, do permit me to share with you another interesting operator called the using operator. Now, as you can see, two tables, which is the order table from this database and the product table from the other database, they are connecting with the same name. So each of them have the product ID name. So when you have this level of similarity, product ID on this side and product ID on this side, instead of using the on, you could introduce a new function called the using statement. Now, because they have identical field names, if the field names were not identical, the using function would not work. Or because it's identical, we can select this and run, and you would get exactly the same result as you desired. It's of interest to note that there are times when you do a self-join, which is joining a table to itself. And let's look at a typical example of instances where we could join a table to itself. So in this one, we'll be using the select function. From here, we'll be using the SQL. So we'll be dealing with the SQL HR database, and we'll be looking at the employee table. Employee table. Now, we're going to give these an alias of E, and then we're going to just select these and run it and see what it looks like for us. You see, every employee has a first name. They have a last name. They have a title. They have a salary. And they have someone to whom they report to. Now, it's interesting. You see, this lady, be a guy or lady, whoever the person is, doesn't have anyone he or she reports to. However, we are not able to ascertain the name of the person to which they report to. So for that reason, we're going to go one step further. Now we're going to join this. So we're going to join that table to itself. Yeah. Now, but we're going to give it a new alias because this time around, we're looking at that for the managerial role. And then we're going to say on, the basis for which we're joining is E reports to equals to and M dot reports to. It's pretty much the same table. Yeah. So we're going to take this and then run that code. Now you can see the employee ID here, the reports to, yeah, so we can do this. Now, this is what we're going to do. To drill a bit deeper, we can remove these now and narrow into specifics. So let's say some of the specifics we'll be interested in will be e.employee ID. So pull this up for us. Pull the e.employee first name. We're also going to look at then the EM plus first name. So pretty much we want to pull the manager's first name. Yeah. So, but we're going to use this as an alias and call this manager. So we should be connecting the E reports to the M employee ID. Yeah. Because we're trying to map this to someone. Yeah. We're trying to map the earlier one to someone. So we're going to select this and run this. Now look at this. You have this employee called Darcy reporting to Yovana, and you have three. Okay, let's bring in their last names so that we see them looking a bit more detailed. Let's look at these detail in a more detailed manner. So apparently, if you look at these, my friends, you would realize that everyone seems to be reporting to the same lady called Yovana, everyone. And because there's a challenge with this, because Yovana herself is reporting to no one, she is not captured in these details. Now, a quick way to get around that, because like I said to you earlier at the beginning, every time we use the join statement, it goes for the inner join. By default, the system sets it to an inner join. But if we go for a left join, meaning every item in the left, which is the employee side, and then the ones that connect to those ones on the right. So if we bring in here and say a left join, yeah, and then we run this, you see, Yovana will come in without a null, with a null, because these statement at the top, at the bottom, kind of drills in only those that have these mapped to this. So if we don't bring in the left join, it's going to use an inner join experience, and then that will leave out Yovana entirely from the feedback we're going to get. But to correctly capture this, we need to use the left join. So this is a very good way, a good place where you use the left join to drill your analysis to get a good result. So please take note of this good use of a left join, and then keep it at the back of your mind as you navigate your journey in the world of SQL. Just like we had the left join, we also have the right join. And there's a good use for it, only that it's a bit complicated to remember. Now, both the left join and the out join, so both left and right joins, are oftentimes called outer joins. Yeah, both left and right are oftentimes known as what? Outer joins. Now, I would beg you, in my own career, I stick very much with the left join because it's always easier to map, to remember, and to understand. So I'll beg you also to keep the left join more closer to your fingers than the right join. Yeah, it's always a lot more harder to remember and to have a clear picture around. We've spoken a bit about the left join. We've also drawn a bit about the right join. Can we at this point talk about what we call the natural join? Now, you see, what we call the natural join, which pretty much looks like this. So from others, and then here we just call it natural join. Yeah. Now, when you do this, it's pretty a simple thing. You don't set a condition by which the join happens. So when you write a code like this or a query like this, and you don't put a condition for the join, that is called a natural join. The system has to intuitively think around what is the best way to join this. So the system is the one who will have to use its head to think for you how to join it. Again, just like I warned you with the right join, the natural join is a risky use of join because you don't understand the basis. You may not be very well aware about the basis for which the system joined that data set for you. And it may not altogether be in your best interest. So it's always good practice for you to be the one to join, to decide on how best you join your tables. There is a last use of join that I would like to introduce to you, which is called the cross join. The cross join is really a random joining, and which could be very good when you are joining two small tables. For example, Nike has different sizes of shoes and different colors of the same shoe. So let's say they have small, they have large, they have extra large, they have. Now, if you do a cross join between sizes and colors, so it means that the yellow will have all the sizes. So yellow, so it will come out looking this way. You would have colors like yellow, having X. You would have yellow having medium. You would have yellow having large. You would have yellow having extra large, etc. Yeah. And likewise, you would also have these repeat itself like in other. So you would have white, white. So each color will take up itself, will take up different sizes. White, you have white. And again, you will have the green. As much color as you have on the color side will take up a combination with the sizes. That's a good use of cross joins. Yeah, it's good for you to have a knowledge around these things, even when you may not often have to use them. Lastly, speaking about joins, there are tables. We've seen how to use primary keys like employee ID as the basis for the joins. I think we've seen that over and again today. So we have reports to, which is the primary keys were the unique identifiers. We use that as the basis for joins. Look at that. Yeah. Now, there are times when a table has more than one primary key. When one table has more than one primary key. So you cannot use just join, and on in that instance. In such instance, we may use something like this. So you have to combine the join, combine the on, and as well combine the and. Now, this is a typical example of a case like that. So select all from others. So others all, yeah, join with customer. So you're going to look at where the customers is with an S, a C. So you give it an alias on O dot customer ID, got that? So this is the first primary key, and here is, so these maps to the one in others, yeah? Likewise, okay, in such instances, so this is a typical one, other items, so order, so here is a typical one, other items, other underscore items, keep it as OI, join. So we're joining that to another table called order underscore item underscore notes. Yeah. So we're going to call this one OIN on OI dot other underscore ID equals to OIN dot. So we're mapping the order ID from the order item table to the order ID on the order item notes table. Yeah. And likewise, and we're doing something, the same thing here. We're saying map the product ID, map the product ID from the order item table, map it to, map this to the product ID on the order item notes table. Yeah, pretty much. Yeah, so we're going to stop this. Yeah, cool. Select that, and then let's see where it takes us. It's empty. All right, let's run this. That returns false. It doesn't mean we're wrong. In this case, it will be good for you to break this down and try to do it independently. So I'm going to break this down and try to run this independently. Now I'm going to run this independently to see what other item brings on board. So let's see, other item. So we've got for other items, we have others, we have others just one, and then product ID being 2 and 2. So order is just 1, and then product ID 2 and 2. Now let's see, let's look at this and run this same code, this one. Now you have order 1. There is an instance where order is 1, but at the instance where order is 1, product ID is 4. Okay, so there is no way that was going to give us any result. For us to get any result from this, we have to say, we have to negate this. Yeah. So we're saying where order ID is the same and product ID is not the same. So if you run this now, you're going to have this experience because at this case, there is an instance where order ID is 1, but there is no instance where order ID and product ID are the same. So you're going to have these outcome. Yeah. Okay. So that is us joining tables that have more than one primary key. Now, lastly for today, I'm just going to show you how to create views. Now, why do you create views as an analyst? The reason why you create views as an analyst is because when you are going to be giving you may want to be able to create a view on your database such that an analyst from outside or somewhere, you just give him a view to see what he is. You don't want him to come into the main database and see what you have really in there. So you pull together data tables and then create a view for him to have that access to just the view. Now, to create a view is really simple. You write create view. Now give the view a name. In this case, we're going to call it first view. First view. Now, and then you're going to say us. Once you do that, you can go ahead and say select whatever. Now you use your read statement, whatever the read statement will be from. Again, this is really up to you. You could use any one of the things that we have discussed today to write the view. Now create view, put the view name the way you want it to be viewed as, then put your read statement. Once you do this, you can run this code and it goes straight. Now, if your view has been created, you would find it here. So I'm going to check right in here, customer table, close this a bit more, look at views. So it hasn't been created here. So it means there is an error in what you've created. So in creating a view, you create view, first view, as, select, asterisk, so everything from a table you are pulling it from, or you could go ahead to drill into whatever read statement you want to do, and then run it. First, you want to check, there might be, if there is an error, you would know it. So tables, customers. So let's see, customers. So view. Now, when you run this, it creates the view. Now, just in case you don't see it, come here, refresh the schema, and then check, go to views. And then you can see first view. Yeah. So this has created a view, and we can now create access for someone using a BI tool to be able to assess this view and make analysis using that view. In our next video, or in one of our videos, we will teach you how to create access for this view and give people privileges to come in and access the view. Thank you very much. Do remember to subscribe, like, comment, and share our videos.